So now that we have the basics of what's happening in a confidence interval, what it is, we're going to talk about how we actually calculate them. And how we calculate them depends on what kind of parameter you want to estimate. So if we want to estimate a one population proportion, then we're going to do a confidence interval for a one population proportion. It's sometimes called a one prop interval, one proportion interval. Think of it that way. And the reason for one is because you only have one population parameter that you're dealing with. Just like in a hypothesis test, you have some certain steps you have to do. You do need to have mosaic turned on, and then you need to kind of state some values. We want to state our random variable, again, what we actually are measuring, and then the parameter that we're actually trying to estimate. Again, these are in words. We don't know what these are. We have no idea what these values are yet. We're just at the start. We're thinking about we want to do something. We want to estimate something, and we're going to go find out what it is. So these are unknown, but in words, they'd be the number of success. Again, you'd put in what success is in your situation, and you have the proportion of success. Again, you'd put in your success, what success is in this case. We don't have hypotheses in confidence interval, so you're going to jump straight to stating and checking the assumptions for the confidence interval. You're going to have a simple random sample of size n is taken. The conditions for the binomial distribution are satisfied, and the sampling distribution can be approximated with our normal distribution. All that's the same. So this is the same as we had in the hypothesis test. So this really isn't anything new. And we're going to go from there. So this is the sampling distribution of your sample proportion, which is the symbol for that is P with a little hat on top of it. All right. These are the same things we do for a hypothesis test, the same calculations, everything's the same. So the checks are the exact same in your hypothesis test. We're then going to find the sample statistic. We're going to do the calculations as our next step. So we can actually call that calculations if you prefer. We've actually already done it. It's the exact same thing that you did for a hypothesis test on prop.test. So it's prop.test. You're going to put in your x values, which is this is what you calculated, what you measured from your sample. You're going to put in your n, that's your size of your sample. And then you're going to say what confidence level you want, and you put that in decimal form. The printout you're going to get is the same printout we got from the hypothesis test. We actually solved this already. You just didn't know it was there. Right here is your 95% confidence interval, and there's what it is. So it's saying that our proportion is between these two values for this sample that I did. It also gives you the sample proportion if you want it. So this is your p hat right here. But we actually just want that confidence interval. All right. Your statistical interpretation is, in general, this looks like I'm 95, in this case it was 95% confident that it contains the true proportion. Again, it's not that the true proportion is in that interval, it's that my interval contains that true proportion. So 95% confident, or whatever percent confident, that my interval contains the true proportion. And then the real world is where you state what that interval is that it is, and then your estimate of what it is. So let's go ahead and do an example of this. Healthy people do all four of these things. They work out 4 times a week. They eat 5 to 7 servings of fruit and vegetables a day. They don't smoke, and they visit a doctor once a year. So what we want to do is we want to estimate the proportion of all Flagstaff residents who can be considered a healthy person. So what I did was I asked 24 students in a previous class, and 3 of them do all 4 of these things. And we're going to use a 95% confidence interval. So let's go through the steps of this. So our first step is, of course, to state our random variable and the population proportion. Actually, I'm going to call it population parameter because it depends on which one you're doing. And in this case, we were counting. So x is it's our random variable. If you want to call that x, you can. And it happens to be the number of Flagstaff residents, because we only care about Flagstaff residents, who are considered a healthy person. My population parameter is the proportion, because that's actually what I'm looking for. I'm looking for the proportion of Flagstaff residents who do these are considered a healthy person. So the proportion of Flagstaff residents who are considered a healthy person. I don't know what this is. I'm trying to find out what it is for my sample, but I don't know what this is. And I can promise you there's way more than 24 people that live in Flagstaff. So this number I got for my sample is not my proportion, but I'm trying to estimate what that is. My next step of every confidence interval is to go ahead and state and check the assumptions. So I always state first, again, this is what we want to happen. This is what you're supposed to have happen. This is the ideal of what's supposed to happen. Doesn't mean it does happen, but it's the ideal of what's supposed to happen. And it happens to be, in this case, that a random, the first one is a random sample of 24 responses of Flagstaff residents is taken. Then we want to check it. So did we have a random sample? Well, the answer is no. This was not a random sample. I'm going to keep doing it even though I violated this one. That means my results of this are not valid. I can't say that this is really what the proportion is because I didn't have a random sample. It was a convenient sample, it's just the students that were in my class. The next assumption is that the properties of a binomial experiment have been met. And then we're going to go check it. And this is where we're going to look at the 4 properties. So there are 4 properties. We have a fixed number of trials, and there are 24 students asked. So that was my fixed number of trials. The next one is that there are only 2 outcomes. Either they are healthy or they are not. The next one is that the trials are independent. Since one student's response doesn't affect another. And then the last one is that the probability is the same from trial to trial, from person to person, let's say. We're not positive about that one, but we can be pretty well assured that that one's probably true. Since it is likely that each person has the same chance of being healthy. So we can now say, so the properties have been met. You do want to kind of end it. You want to kind of conclude, here's what my check was, and I now conclude that. Then the next one is that the sampling distribution. So again, we're going to state the sampling distribution of the sample portion can be approximated with a normal distribution. So that's again my stating. Now we're going to check it. The check is where we do n times p, but we don't actually have a p. We don't know what that proportion was. We don't have a known value that we're comparing it to. So we can't do n times p. We're going to substitute in n times p hat. It's not really the right way to do it, but we're going to do that. So we had n was 24. P hat would be there was 3 people out of the 24. So we get 3, which unfortunately is not bigger than 5. So we have a problem. We're also going to do n times q, but n, we don't have a q either because we don't have p. N times q is really n times 1 minus p hat. So we're going to use q hat and p hat again. So it's going to be 24 times 1 minus 3 24ths. And that would be 24 times 21 24ths, and that is 21. So that is bigger than or equal to 5. But unfortunately, the 1 wasn't, so there was a problem. So these may not be valid. And there's not much we can do about this. We're just doing an example here, but if it's not, then you didn't take enough big enough sample. So we would probably say the sample wasn't big enough. Or say the sample needs to be bigger. All right. So now that we've done our assumptions, our next step is to do the calculation. So we're going to do those calculations. We're going to use RStudio for that. So I'm going to go into my RStudio. I'm going to make sure that I've gone into my packages, make sure that I've turned on Mosaic. If you want to do an RMD file, you're more than welcome to, or you can use the console. It's up to you. I just want to make sure Mosaic has been turned on. So I'm going to come down through my list here, and Mosaic has not been turned on. So I'm going to turn on Mosaic by clicking the box right next to the word Mosaic, and that will turn it on. And then it is prop.test that we're doing. We put in our X value, that's how many I actually found. 3 of my students did this. My N value is 24, because I had 24 students. And then I could do a conf.level equals 0.95. It actually assumes it's 0.95. So you might need to go and put that in, or you might not. It's up to you. I actually didn't give you that percentage. So let's go back and look at the problem. I actually didn't give, oh, I did say 95%. So we do want to have a 95%. So we are going to do our 95% here. Again, R assumes it's 0.95. So if you forget to put that in, it's not a big deal unless you're changing your percentage. So we'll hit enter. There's our calculations. And I can go put these in here. And so here's what I typed into R. And then here's my calculations. And so it says a 1 sample proportion test with continuity correction. Don't worry about that continuity correction. It's how it does the calculation, but we do want to make sure it does say 1 proportion test because we are doing that. It does tell me my data that I typed in. Then it tells me these things here I don't need because this is for a hypothesis test. So these first few statements here are just for a hypothesis test. We're doing a confidence interval. So down here it says 95% confidence interval. So there's my interval. It also gives me my sample interval if I want that. And now I can come down here and I can say that 0.033, let's say, is less than P, is less than 0.33. Guess I better round this up to one more decimal place. So 0.339 329 to 0.335 is my proportion. All right, so now I can get to my conclusion and my interpretation. So this is actually what we call the statistical interpretation and then the real world interpretation. So my statistical interpretation is that I am 95% confident that the interval 0.0329 is less than P is less than 0.335 contains the true proportion of Flagstaff residents who are considered healthy. That's my statistical interpretation. My real world interpretation is that, well, what percent did I find? The proportion of Flagstaff residents who are considered healthy is between 3.9% and 3.29. Sorry, didn't mean to do that. 3.29. 3.29% and 3.35%. And that's it. Notice I don't have my 95% in here. I'm just giving what the proportion is I found. And that's how we do a proportion about confidence interval.